Good afternoon, everyone, and welcome to the Skyline Hatch Revision Exam Series in partnership with UBS for Specialist 4. My name is Paishula, and alongside Chelsea and Nan, we'll be the tutors managing today's presentation. However, I'd like to begin by thanking UBS for their incredible support for this revision series. It is thanks to UBS that we're able to deliver this program for VCE students, and we are also so fortunate today to have some amazing volunteers from UBS on this webinar to help us answer your questions and moderate the presentation. So a special thanks to Ben and Patrick for being here today. Before I get started with some introductory information, I'd like to read an acknowledgement of country because the vast majority of us are joining this Zoom from Indigenous lands. I acknowledge the traditional custodians of the land we are gathered on today. I pay my respects to the elders, past and present, for they hold the memories, the traditions, the culture and hopes of Aboriginal and Torres Strait Islander peoples across the nation. Just a little bit of housekeeping in regards to this Zoom webinar. First and foremost, please be respectful in all communications you have during the conference. As well, if you could you please use a Zoom chat just for immediate questions? Just for instance, if you're having trouble seeing the Zoom video or seeing audio, hearing audio, as well as seeing content slides as they appear. However, for all content-related questions regarding to the questions we present, as well as any ideas and topics we analyze, please use Mentimeter to ask those questions. So for now, could I please ask you to all go to www.menti.com and use this code here to enter the Mentimeter for this webinar. Additionally, note that the code is always on the bottom of each slide as well, in case you forget. And just for a quick exercise to practice using that, could you please go onto the Mentimeter and quickly just show how confident you're feeling about the current specialist exam as well. So again, please go onto the Mentimeter website and use that code, and we'll quickly see a quick test of how that works. So at this stage of your specialist journey, I can understand a few of you will be a bit apprehensive about the final exam, but please note that it's all a matter of how much you put in and how much effort you put in. And you've all done so well to even try and get through this year with all these changes in regards to your structure and everything like that. So no matter what your sponsors are, I can see a few of you are feeling fairly confident, but a bit average at this moment. But just know that today's revision lecture is really about trying to build up your confidence and just make sure you guys know how much you have prepared, what you may have to focus on in the future, and as well, just noting everything you really need to know to do as best as you can for the final specialist exam. And just a quick extra note, we'll be using Mentimeter throughout today's presentation to answer and engage with you guys in regards to your questions and any worries or concerns you may be having. So if you do have a question about the content we're presenting, please feel free to just ask the question on the Mentimeter. For instance, someone's already asked a question I see. So if you have a question, please feel free to just type it in and we'll get to that during designated question and answer times during the presentation itself. But with that being said, I'll quickly go back to this content slides and begin with a quick introduction about who I am. As I mentioned before, my name is Paishula and I graduated from Melbourne Grammar School in 2020. So I can definitely empathize with you guys a bit about having COVID interrupt your final year of schooling, and for some of you, your final part of high school as well. I'm currently studying a Bachelor of Biomedicine at the University of Melbourne, whilst also attending Trinity College. I'm having a great time here as well. I'm hoping to pursue a career in medical research and or pharmacology, but of course, as my life continues, I may find new passions, but right now, that's what I'm currently aiming for, I think. However, outside my studies, I love watching and playing a variety of sports. My favorites, of course, being soccer, basketball, and NBA, the Premier League in particular, go Manchester United. And I'm also a big fan of languages as well. I see Ben shaking his head, but Manchester United is a better team. But I'm a big fan of languages as well. So I've done French for the majority of my schooling, from year 7 all the way up to university now. And I'm definitely going to continue doing that in the future as well. I must, however, admit that whilst maths is one of my most enjoyable subjects, my favorite of all would have to be English. But that won't impede my delivery of this specialist vision series, trust me. And now I'll quickly pass over to Chelsea as well to introduce herself.
Hi, everyone. I'm Chelsea. I actually graduated in 2018. So lucky for me, or kind of unlucky, but it's been a while, but I've been doing a lot of maths in uni, and I'm actually looking to do a master's next year, specializing in maths and science. Currently doing data science at the University of Melbourne. And unlike Paish, unfortunately, I do not like English, so I cannot relate to him at all. And yeah, just trying to enjoy lockdown as it is. So looking for a puppy to try raise a puppy in lockdown. So if anyone, can link me up with the puppy, let me know during the breaks. Cool. So I'll pass it on to Patrick to introduce himself.
Hey guys, I'm Pat. I'm a cadet at UBS, and I graduated from Baulkham Hills High School, which is in New South Wales, last year. So I'm at most a year older than you guys. My favorite subject is probably mathematics. I did enjoy Latin as well, but I had to drop that in my final year. But anyway, I love mathematics, and it's the one that I excelled at most. So I'm glad to be here to, lend a helping hand to the Skyline volunteers. In terms of sport, I used to play rugby and touch footy, and I followed the NBA quite devoutly as well. Go Bucks. I'm glad they won the finals. Been supporting them for a few years now. And yeah, I have a dog. He's actually sleeping right under my desk. So if you see me like dropping food, then it's probably to my dog.
Hi everyone, I'm Ben, and like Pat, I'm a volunteer here from UBS, where I work part-time as an analyst, while I'm actually still completing university, which I'm in my last year of undergrad for. I study commerce at the University of Melbourne, and I've also taken a few elective subjects in mathematics, so I've continued my maths journey into uni. At school, I undertook specialist maths as well, so I've been through the experience that you guys are currently, so hopefully got a few experiences and tidbits to share. And sporting wise, like Bashala, I follow the Premier League. However, I'm an Arsenal fan, so just a little bit of conflict there, but I'm sure we can work through it.
Awesome. Thank you, Patrick and Ben. Today, we're also supported by Nan, who's going to do a lot of the work with answering question stuff. So if I could pass to her as well.
Hi everyone. I'm Nan, and I'm Skyline shooter. Currently, I'm studying Bachelor of Science and Bachelor of Biomed at Monash. So I'm on Chelsea's side. I hate English. I don't like English at all. And yeah, I look forward to work with you guys today.
Awesome. Thank you, everyone. I'll quickly go through a quick overview of the agenda for today's session. So as we've been doing for a little bit now, the first 10 minutes or so will be going into the introduction about who we are, what we're currently planning to do, and also some housekeeping issues. And afterwards, we'll be going straight into the content blocks. As you can see, we're covering a lot of content, the entire Specialist 3-4 course, over the course of 3 hours. So as a result, we will be going quite quickly through everything, but just note that the entire presentation today is focused on supplying you with the most relevant and most pertinent information to help you with your exam preparation and to help you for making sure you're aware of what you may have to cover in the future to be fully on top of everything. So we're going over area study 1, area study 2, have the quick break where I'll be able to answer some questions as well, do calculus after that, have another break, and then I'll quickly finish off with vectors and mechanics. And then after that, I'll hand it over to Chelsea, who'll be taking care of the probability and statistics part of the course, as well as finishing with a Q&A and just a check-in about how you guys are feeling about the exam itself. Like I mentioned before, we'll be using Mentimeter a lot today to go over and answer your questions. So feel free to, at any point during this presentation, look at Mentimeter and respond with what you're feeling, any concerns you may be having, as well any general advice you would like about reading time, for instance, how you want to prepare for the exams, how would you want to prepare the day before or the week before your exam. Any questions you may have, we'll feel free to answer during those question time periods. As well, just a quick overview of the expectations. Obviously, because we only have 3 hours today, we won't be able to cover every variation of every question in today's webinar. However, over the next few sessions, next few hours, like I mentioned, we'll be addressing the most crucial and commonly tested elements of the study design. As a result, what we'll be doing today is providing you with the key content points, demonstrate how examiners test your understanding, and hopefully highlight areas that you may need to revise further in the future. We'll also be primarily doing this through a lot of practice questions, because that's probably the best way for you guys to see how examiners actually try and test your understanding. So we'll be doing a lot of practice questions with you guys, just to show you how this content is actually applied in the exam environment. With that being said, I'll get started with the first area of study for today, which is functions and graphs. As you probably all know by now, functions and graphs comprises the main foundation of the VCE syllabus of specialists, because pretty much everything comes back to our understanding of functions. As well, there are many questions, especially in exam 1, where graphing is important. There's usually always at least one graphing question in the exam 1 for specialists, and guaranteed at least 2 or 3 in exam 2. And as a result, it is important to make sure we are aware of how to graph certain functions which do pop up in specialists. I guess the best way to introduce the idea of functions and graphs is to give a very general overview of what they appear as in the specialist sort of syllabus. So initially, we begin with the idea of the rational function. So a rational function is of the form p of x equals f of x over g of x, which of course f of x, g of x are just different functions of x. The issue for rational function is, like with all fractions, if there is a fraction as a part of the function, if the denominator equals 0, therefore the function is undefined. And therefore we will be seeing asymptotes for these sort of functions, which is summed up in the idea that g of x cannot equal 0. In specialist, we are expected to graph these sort of functions. However, because they're quite unique in their nature, like you can have any function of x as f of x and any function of x as g of x, there can be quite interesting and quite difficult cases. However, there is a very formulaic approach we can take to make sure we can respond to these sorts of questions. So the general method for graphing a rational function p of x is to initially factorize the denominator if we can, identify the vertical asymptotes by solving the denominator for 0, identify the horizontal asymptotes by understanding the graph at extreme values, or even more easily, by thinking what happens when y equals 0, and additionally, identify any intercepts that are involved. Like I said before, the best way to encompass this information and make sure you guys are fully okay and comfortable with these ideas is to attempt a question involving them. That being said, just note as well that when we do questions, I'll be jumping over to my OneNote so you guys can visualize that. And please note as well, you'll be able to access all the work solutions for these questions after the revision series as well. But initially, we have this question here, which is a very common one in specialists, where we're asked to sketch the graph of f of x equals x plus 1 over x squared minus 4 on the axes provided, making sure to label any asymptotes of the equations and any intercepts of their coordinates. So off the bat, this function is not something you can straight away look at and think, yep, I know exactly how to graph it. However, if we fall back on the steps we're aware of, then we can quite easily try and formulate a plan to graph this function. So first of all, the first step will be involving to try and factorize the denominator. So for f of x, if it equals x plus 1 over x squared minus 4, all of you will be able to see by now that this is just a difference of perfect squares. So that's just x plus 2 over x minus 2, factorizing the denominator. After we do that, it's much easier to work out what the vertical asymptotes are. So remembering again, vertical asymptotes pretty much tell us what values of this function x cannot be. So to do that, you think, when is the denominator equal to 0? The denominator is equal to 0 when one of these two brackets are. So therefore, there are vertical asymptotes when x plus 2, x minus 2 equals 0, and therefore we have x equals negative 2 and 2. So straight away, we know already that on this graph, there will be asymptotes at x equals negative 2 and at x equals 2. The next step will be to work out what the horizontal asymptotes are. So the horizontal asymptotes occur when there can be no possible y value for a certain coordinate. One way to do that is to work out what if f of x equals 0. Well, if f of x equals 0, we have this function. And noting that with fractions, we can simply swap these denominators. So this can also be equal to x plus 2, x minus 2 equals x plus 1 over 0, which is, of course, undefined. So noting that in this function, you can swap denominator with f of x means that when f of x equals 0, this function is also undefined. So this is, of course, undefined. Therefore, if we know that f of x equals 0 is also an asymptote, we know the line that y equals 0 is also an asymptote. And finally, for a question like this, and note that there is a bit of working out, but that makes sense for a 4-mark question such as this, we have to make sure we get the right intercepts. So for x intercepts, we have the case of y being 0. So therefore, 0 equals x plus 1 over x plus 2, x minus 2. And therefore, this just means x plus 1 equals 0. And therefore, we have -1, 0 as a point, where x equals -1. Noting that for this to equal 0, denominator has to equal something, but we can multiply both sides by the denominator. And we're left with this equation, x plus 1 equals 0, which solves for x equals -1. So we know, therefore, that the x-intercept occurs at -1. We have a point here of -1. For the y-intercept, we can see the case when x equals 0. So we have f of x equals 0 plus 1 over 0 plus 2, 0 minus 2, which is, of course, just 1 over -4. And therefore, we have another point, 0, -1, 4, as the y-intercept. So look on this graph, we have something like here. And therefore, after we get those two intercepts, we can quite easily see how this graph looks like, noting that each graph has to lean towards the asymptotes. So if that's the case, if we have a point here, we can draw a graph looking like this, being as careful as you can with how we draw it, noting that it has to curve towards the asymptote. So I'll repeat this until I get that effect. It has to curve towards the asymptote. And equally, all graphs outside the original domain have to equally curve towards the asymptotes. So just to make this as clear, that isn't as clear as can be. Give me 1 second while I make sure this is as accurate to the graph as possible. There we go. So just noting that for specialist mathematics, they test a few things. Firstly, if they say label asymptotes, they will test that for one of the marks. We've given y equals 0, and we've given the x asymptotes as well. They will test the coordinates of the intercepts they've calculated. So we worked out here that -1, 0 is an x-axis intercept, and that 0, -1, 4 is a y-axis. So they'll test that from another mark for the question. And equally, they will test shape. So making sure the shape of your graph matches what each of these values should be. And after that, that's pretty much all you have to do for this sort of question. The key thing to note that in the actual exam, the most common mistake for this question was that people forgot the asymptote y equals 0. Because that occurs on the y-axis, it is the x-axis, sorry, it is quite easy to forget. But note that there is another asymptote that you will have to mention in order to show the real understanding of what this graph actually means. So with that being said, I'll quickly return back to the content. So that was an example of a rational function graphing, which is very common in specialist mathematics, especially in exam 1. So hopefully you guys are comfortable with that sort of premise now. The next thing to cover in this first area of study is trigonometric formulae. So just note that on the formula sheet that will be given in exam 1 and exam 2, you do have the formulas given to you. However, it is much more efficient for yourself to have these sort of ideas memorized and have this sort of content memorized, because as a result, you don't have to keep flicking to the back of your revision sheet to work out what these formulas are. You instead have the back of your head and can quite easily implement them into the questions you're actually trying to answer. With that being said, I'll do some more questions as well to show you how you actually use these formulae to actually answer questions in a practical sense. So initially, we have the trigonometric formula question that the 3-marker, given that cos x minus y equals 3 and 5, and tan x equals tan y, find equals 2, find cos x plus y. So for these solved questions, there are a lot of steps involved. Just note that today, Chelsea and I will be showing you kind of an overworking of these solved questions, just to make sure you guys are aware of all the steps we're doing. However, note that in the actual exam, you should always tailor how much working you show to how many marks are offered for the question. If it's a 1-mark question and you can solve it in 1 line of working, that's all you need to do. But if it's a 2-marker, 3-marker, note that they are looking to give working marks as well as just the answer mark. So with that being said, I'll go to this question now. So given that cos x minus y equals 3 and 5, and tan x tan y equals 2, find cos of x plus y. So using the understanding of the formulas, we can quickly create some simultaneous equations to try and work out what this is. So if cos x minus y equals 3 and 5, we can apply the trig formula for cos x minus y, and therefore state that this also equals cos of x, cos of y, plus sine of x, sine of y. And it's having in the back of our minds that that's the first equation we've kind of worked out. This equals 3 and 5. We're next given the idea of tan x, tan y equals 2. As we all know, though, tan is just another way of saying sine on cos. So this is the same as saying sine of x over cos of x multiplied by sine of y over cos of y equals 2. We can multiply the denominator by cos x, cos y, as well as the other side, to rearrange this to being sine of x, sine of y, and then bringing the 2 cos x, cos y to this side, minus 2 cos of x, cos of y equals 0. And let's call this equation 2. So as you can see here, what we did was just change the form of this tan x to sine, bring this to one side, then minus it in order to get this equation, therefore this relation between the two. Now, let's put these equations together to try and work out what cos x plus y is. So adding these together, or actually let's minus these to get rid of the sign. So 1 minus 2, so equation 1 minus equation 2 will give you cos of x, cos of y. The sine x, sine y is cancel out, and you're left with minus 2 cos of x, cos of y, which is therefore 3 cos of x, cos of y. And note that we were also doing, in this case, 1 minus 2, 3 minus 5, 3 on 5 minus 0. So this equals 3 on 5, and therefore we get, if we divide both sides by 3, cos of x, cos of y equals 3 on 5 divided by 3 equals 1/5. And therefore, from equation 2, we got that sine of x, sine of y equals 2 times cos of x, cos y. And therefore, we can also state sine of x, sine of y equals 2 on 5. If that's the case, let's now return to what the question is asking us. Cos of x plus y. Again, we can use the revision sheet in the back of our dial books, or just from our knowledge. Cos of x plus y equals cos of x cos y minus sine of x sine y, which we've worked out from these equations here. And therefore, this just equals 1 on 5 minus 2 on 5 equals 1/5. A good check at the end of doing a question is always to refer back to what the question is asking to make sure you've actually responded to it. So we were given two formulas, and we're told to try and find cos x plus y, and that's what we've done here with an answer equaling cos x plus y with a negative in front of this here. So this finally results in -1 on 5. And that's a classic sort of trig formula question where you're asked to use your knowledge of the trig formulas and try and implement that to respond in this sort of environment with like new values and new variables added to it. With that being said, we're turning back. Just to show you guys another sort of topic that is quite common in methods, in specialists, is the area of study of algebra. So as you know, algebra is throughout specialist mathematics, solving for variables, solving for different equations. However, in specialist maths, in contrast to methods and further stuff, we also solve over C, solving over, in this case, the complex realm. So we'll do a quick review of this sort of idea. And the best way to show you this is to actually do a question. So let's return to our OneNote and try and do a question that puts into place our understanding of complex numbers and solving in the complex sphere. So let z cubed plus az squared plus 6c plus a equals 0, where z is a complex number, where a is a real constant. Given that z equals 1 minus I is a solution to the equation, find all other solutions. Well, firstly, what you'd apply is what we call the conjugate root theorem, which you have definitely come across in specialist. So just a quick reminder, though, the conjugate root theorem states that if all coefficients in a polynomial like this has real values, so as we can see, it's 1, a, which is said to be real, 6, and a, if solutions come in pairs, so a plus or minus bi are solutions. And that's what the conjugate root theorem states. And therefore, if z equals 1 minus I is a solution, if z equals 1 minus I, therefore z equals 1 plus I is also a solution. It's also a solution. Now, there are a few ways you can then solve for the next sort of solution, knowing that there probably is a maximum of 3 because it's z cubed. You can substitute values in and see if it equals 0. For instance, z, let's say z equals -1, z equals 1, z equals 2, z equals -2, that. Or to make sure you get a guaranteed answer, what you can do is now write out this polynomial in the form of the solutions you have obtained. So if you know that z equals 1 minus I is a solution, you also know that z1 plus I is how you'd write that in the polynomial, and equivalently, do z1 minus 1 minus I for this solution. So meaning that if either of these equal these solutions, this bracket will equal 0, and therefore the entire thing will equal 0. However, there's one solution we haven't found, so let's just call that z minus b. And then we do something that's very common in maths. We try and equate coefficients on both sides after we set up this first equation. 6c plus a. Therefore, to do that, let's just expand this a little bit. So in this case, we get z squared minus c minus iz minus c plus 1 plus I plus I of z minus I squared times z minus b. And now I'll simplify this to make it easier for ourselves. So we still have z squared. We know that the negative z's come together equals -2z. We know that the iz cancels out and the i's cancel out. And we're also left with a negative I squared here. I squared, of course, is being -1. And therefore, we add that to -1 is +1. Add that to this +1, and we're left with +2 here. So fairly straightforward so far. And then what we do here is something that comes very common in specialists. We equate coefficients. So let's first consider what's in front of z squared in this case. So if we look at this side, what will be z squared? We have z squared times negative b. So we have negative b. We have negative 2z times z. So negative 2. And on this side, we have an a in front. So this equals a. Let's think about the constant term. So what has no z in front of it? The constant you have on this side, plus 2 times b, so negative 2b. Then we have a on this side as constant, and therefore this equals a. And therefore, after we've worked this out, we can input this into this first equation. So therefore, negative b minus 2 equals negative 2b. And therefore, b equals 2. From that, we've worked out the last solution, and therefore we can state, remembering always, always, always refer back to the actual question to work out what you're meant to be given the answer in terms of. So we're asked to find all other solutions, and therefore we can state other solutions are z equals 2, z equals 1 plus I. And that's how we try and answer this sort of complex number question. Another key component of complex numbers is the idea of de Moivre's theorem and polar form. So just a little bit of content before we go into question on that. So another way of expressing a complex number outside of just doing x plus yi is giving it in polar form. So we know a complex number has some component of I, but we can express a complex number in terms of theta and an angle as well. So we express it not by its real and imaginary components, but by its angle, which satisfies the equation tan theta equals y on x, and its magnitude, given by r equals Pythagoras, so root x squared plus y squared. Then we write it in this form here, r sin theta, which is the same as r cos theta plus I sin theta. So you've definitely done a lot of these sort of questions converting from polar form to Cartesian, from Cartesian to polar form. And therefore, what examinations will actually test you on is your ability to understand the concept of polar form and then extrapolate that to harder situations. For instance, in terms of multiplication and division of polar forms, as well as de Moivre's theorem. When you put a complex number to a power, how can you then use that to express a new polar form of that complex number? So again, multiplication, just note that that's adding together angles and multiplying R values. And for division, it's dividing R values and minusing angles. So on top of all this, we have the de Moivre's theorem again, where if you put a complex number to a power, that equals just the R value to that same power, and then that angle multiplied by n, noting again that that angle has to be between negative pi non-inclusive and pi inclusive as well when you actually write it out. Okay, the best way to actually show you all the information is to do a question putting those ideas to the test. So the question we're given is find the integer values of n for which 3 minus root 3i to the power of n is real. The first thing we want to do is to convert this to polar form. So we have r equals root 3 squared plus negative root 3 squared. So therefore this equals 9 plus 3 is just 2 root 3. And equally, the angle just equals the inverse tan of b on a, so negative root 3 over 3 is negative 1 on root 3, which equals just negative pi on 6. And therefore, this in polar form is just 2 root 3 cis negative pi on 6. If that's the case, we remember we go to polar form because that's how we can actually solve questions where it's given to us in the power. Therefore, this to the power means that 2 root 3 is to the n and cis negative n pi on 6. The question is asking us to find the integer values of n for which 3 minus root 3i to the power of n is real. Noting that it is real when there is no I component, when there's no I when you actually expand this out. If you remember, cis theta is just cos theta plus I sine theta. So essentially what it's asking is when is sine theta equal to 0, which will mean there is no I term when you actually expand this out. So therefore, ultimately what we're solving is kind of when is sine negative n pi on 6 equal to 0 for real values. And therefore, if we just solve this in our heads, we have when is sine of something equal to 0? If you look at the Cartesian plane, sine equals 0, the y value equals 0 when we move some amount of pi around the unit circle. So therefore, negative pi on 6, or just n pi on 6, because it doesn't matter if you have negative in this case, equals some value of pi, let's say k pi, for k is an element of z, and therefore solving for n, therefore n just equals, divide both sides of pi on 6, 6k, where k is an element of z. In this question, the most common mistakes were not defining what k is, noting that k could be anything, it could be L, it could be M, it could be any value. We just use k to state that for however many amount of pi, that is when sine equals 0. And then we solve for n just by dividing both sides by pi on 6. The next question is asking us, find the integer values of n for which 3 for the same bracket to the power of n equals ai, where a is a real number. Noting that in this case, what happens is there's no real component. There is no cos theta. So if we still have 2 root 3 and cis negative n pi on 6, what we have is we're looking for cases where cos of negative n pi on 6 equals 0. Therefore, when is cos n pi on 6, or when is anything of cos equals 0? When it lies on the y-axis, and therefore looking at stuff where n pi on 6, because again, the negative doesn't matter in this case, equals pi on 2 plus some movement around. So if you know that pi on 2 results in cos equaling 0, anything adding pi to that will also result in something landing on the y-axis. So therefore, this just equals pi on 2 plus k pi, where k is again an element of z. And therefore, we have n just equals, if we divide everything by pi on 6, 3 plus 6k. So this was very much a conceptual question. So you have to apply your conceptual understanding of what the polar form is, of what putting it to the power of n actually means, and just using your understanding, your foundational understanding, and applying that to a new idea, the new idea meaning, when is it real? When is it a complex number? And when is there only a complex variable, when there's only a real variable? And you solve that by trying to find when the other equals 0. But that's kind of just juggling your ideas of, again, just the Mars theorem, your understanding of polar form, and how the unit circle actually appears. So again, just checking, we found what question wanted us to find. We found integer values of n in this case, where n equals 6k, where k is integer, and integer values of n, where a is real number. We found values of n here, where k is again integer and n is integer. So as a result, we should be very happy with how we responded to that question there. With that being said, we've now covered a lot of what de Moivre's theorem and polar form applies, especially in the hardest case. So this is one of the hardest solved questions that appears in relation to this. Additionally, the last little thing we want to cover quickly in regards to algebra is partial fractions. So partial fractions are used to decompose rational fractions into components that are easily integratable. For instance, we have an idea of x squared minus 3 over x squared plus 2 times x minus 1 equals some new fractions. And we try to work out what these new fractions are. Noting again that the main reason we do this is to integrate these sort of fractions. It's much easier to integrate separated fractions like the one we have on the right-hand side here than on the left-hand side when you have multiple functions of x which aren't easily integratable, such as this. However, one thing we can do to make it easier for ourselves to actually work out what fractions we try and make from an initial fraction is work out which factors relate to which partial fractions. And thankfully in Specialists, there are a lot of really easy tips and tricks that help us to answer these sort of questions. So what factors relate to which partial fractions. So the one that's most common is just a distinct linear factor. For instance, let's do 3x minus 4 over, let's say, just 2x minus 3 and x plus 5, for instance. If that's the factor, and it's just two linear factors on the bottom where x to the power of 1, we just separate this as equaling, this equals sum a over 2x minus 3 plus sum b over x plus 5. And noting that the way you then solve for this is then just do a times x plus 5 plus b 2x minus 3 equals 3x minus 4. And then just set up simultaneous equations to solve this. Additionally, you can also have repeated linear factors. So let's say again, you have 3x minus 4 over, let's say, 2x minus 3 squared times x plus 5. In this case, this equals a over 2x minus 3, b over 2x minus 3 squared, because it's a different denominator, and then c over x plus 5. Now, noting there are 3 different fractions you have to calculate, noting as well that a, b, or c, one of them could be equal to 0. You don't know, you just have to work that out by working out each of these values, again, by just putting together a simultaneous equation and solving for that. The harder one is, of course, when there's an irreducible quadratic in the denominator. So, for instance, 3x minus 4 over 2x minus 3 multiplied by x squared plus 5. So again, x squared plus 5 cannot be factorized or put down anymore. Therefore, we have a over 2x minus 3, that's a linear factor, plus bx plus c over x squared plus 5. Again, you'd still solve any other way. You then do a times x squared plus 5 plus 2x minus 3 times bx plus c equals 3x minus 4. Note that these are very common factors to partial fractions. You'll see these things a lot. I'm sure you guys have quite a bit of experience already dealing with it. Note that it's very, very common to see a partial fraction question, so we'll try and be as comfortable with this as possible. And note that all of this is in the textbook. It's quite familiar to you guys, and it's quite often tested, so you should be being comfortable with this as possible. The best way to show you how we actually solve a partial fraction question is to do one. So if that being the case, I'll jump to one right now and show you guys how we try and work through the process. So here we have verified that 5x cubed plus 12x plus 4 over x squared plus x plus 4 can be written as 1 over x squared plus 3 on x plus 2x minus 1 over x squared plus 4. It's only one marker, which is quite a shame because it's quite a bit of working to show this is the case. But still, to get that one mark, we have to strictly show all the steps. So to do this, we first try and break up this partial fraction. So therefore, we know 5x cubed plus 12x plus 4 over x squared plus x squared plus 4 equals, in this case, a over x squared plus b over x, notion that x and x squared are different partial fractions, plus this is an irreducible quadratic, so cx plus d on x squared plus 4. And then you just set up the equation. So therefore, you have a times what you have to multiply x squared by to get this final denominator fraction, x squared plus 4, plus b, you have to multiply by x and then by x squared plus 4 again. So let's chuck an x here and then x plus 4. And for cx plus d, you have to multiply this by x squared. And we're told that this equals, on the numerator, 5x cubed plus 12x plus 4. And then what you do is just equate coefficients. So let's say for x cubed, what do we have on both sides? For x cubed, there's nothing a, there is a b, and there is a c. And on this side, there's 5 in front of the x cubed. For x squared, we have a x squared. We have no b value, but we have a d value. So a plus d equals 0. Therefore, we can state that a just equals negative d. That'll help us out later, I imagine. And for x, we have 4b equals no c value or d value, 12x on this side. And therefore, we can work out here that b equals 3. If b equals 3, then on this side, we can work out c equals 2 as well. And finally, for the constant term, on this side, we have a times 4, so 4a. We have no constant term here, no constant term here, 4 here. Therefore, a equals 1. Therefore, d equals negative 1. After you've worked all these out, we can quickly write out the fraction. These fractions hopefully will equal what we're given in the question here. So therefore, we have 1 on x squared plus b on x plus 3 on x plus cx plus d over x squared plus 4. C is 2. D is negative 1. And then we have x squared plus 4. And we say this equals RHS. And therefore, it has been verified. So quite a few steps involved for a simple 1-mark question. But note that to verify something, you have to show you're working out to show how we go from this to this. And this is a simple sort of way just to equate coefficients and stuff. Too easy. So returning back to content slides. That's pretty much all we had to go through in terms of just the introduction to area of study 1 on functions and graphs, as well as algebra. With that being said, before we go into a quick break for you guys, I'm going to answer a few of your questions now. So jumping over to the Mentimeter. To answer some questions. So initially, we had the question, how should we use reading time in exam 1? So again, noting that you can use Mentimeter anytime to ask questions. Going back to the code up here, 49420366, and that's on every PowerPoint slide as well. And feel free to answer any questions that come to mind. So the question is, how should we use reading time in exam 1? So in exam 1, you're given 15 minutes of reading time and then 60 minutes of writing time. And as a result, it may seem like quite a lot of reading time, but it is really a skill in and of itself to use that reading time to absolute benefit. The best things I'd recommend is, of course, read through the paper, read through all the questions, and then try and plan in your head how you're going to respond to it. So do you see a hard question at the very end that you know you will have to dedicate quite a bit of time to? Do you see a few questions at the beginning of the paper they can kind of whiz through and get out of the way quite easily? Reading time is pretty much a way for you to plan your responses to the entire exam. As a result, it's imperative that you use reading time in exam 1 to try and, first of all, get a grasp of what the questions are involving. And as a result, after you've read through a question, even if you're not attempting it, your brain is slowly working through that question in the background in your subconscious. So even if you saw a question and thought, okay, that question's on partial fractions, but like you don't do it until like halfway through the exam, the thing is your brain is still thinking about partial fractions in the background and try and like coordinate how you respond to it. So therefore, you have no surprises in the exam if you've already read through it and know exactly what question each question will do. And the one thing I do not advise is to try and start doing the paper in reading time, like trying to answer the first 2 questions in reading time. If you've like read through the paper, if you're fully okay with it, then maybe, yeah, start doing it. But what you should not be doing is in that first 15 minutes, just trying to work through the paper. What you should be doing is trying to work out how will you respond to questions, what questions exist in the paper, and therefore get an idea of how you'll coordinate your responses over time. So that's what I would like to recommend for exam 1. With great first question. Any revision tips in the month leading up to the exam? So what I recommended and what I found really useful and was recommended to me by past students was to go through all the mistakes you made in your practice exam. So I imagine in the practice exam, in like the time before your exam, you guys will be doing a lot of work, just like practicing, doing practice questions, practice exam questions. And you'll hear stories about kids doing like an enormous amount of practice exams. Just note that the only real benefit of doing that is learning from your mistakes and actually improving after you get something wrong. So for me, the best advice that I could give is like in the month leading up to it, look through all your practice exams or look through your bound book and look through the questions you got wrong, look through the mistakes you made and see if you actually now know how to do those more difficult questions and how you've actually improved and found responses to them as well. So actually learning from the mistakes you have made will actually improve yourself down in the long run and actually help with that. Additionally, I think the examination report, the one that VCAR publishes, is also something that could be helpful to look at as well, because the examination report has a lot of advice in there about how they've changed the exam or added new questions as well to try and catch students out. So reading through the examination report for the past few years will really help you as well, seeing in terms of where students have gone wrong in the past, what can really help you improve in terms of a special student, and like what examiners are trying to test you on more so in the future. Chelsea, Nard, do you guys also have any advice as well you may want to give like leading up to the exam?
Yeah, I definitely agree with everything you said. I guess I would also add that like some people get really stressed about how many practice exams they can do, but like Paige said, it's not about the number that you do. It's really, are you doing them in like serious time conditions? So it doesn't matter if you do 50 exams, if you're all doing them like while eating at the same time, taking 2-minute breaks every question, you're not getting good enough practice. So it's really about doing them in serious conditions to try and imitate what the real exam will be like. And also making sure that check over your wrong answers, of course, but also check over the ones that you got right. Don't just check if you got the same answer as the VCAR report. Check if you've done it in the most efficient way. Check if you're following what the example answers from the VCAR reports are telling you how to get the marks. Because sometimes you can get the same answer, but you might not get the working out marks. So just really be thorough whenever you're going over an exam to make sure that you get the most out of, doing the practice exam.
Yeah, definitely good for that. Awesome. So yeah, that's a very important sort of question because that month leading up to it can be quite stressful. But like Chelsea said, it's all about improving over time and seeing where you made mistakes and like doing the absolute best that you can. Additionally, do you need to show working out when graphing? No, you do not have to show working out for graphing. You don't have to show working out of everything. But if you have your working on the side to show like how you calculated the intercepts or how you calculated the asymptotes, that will be useful. It does depend on the question. If, for instance, it's a 2-marker, for instance, the question I did for you guys just then, it was a 4-marker, which as a result means that they probably do want to see like some working as to like how you found the intercepts and stuff. But for a 2-marker, that graph that I showed you could easily have been a 2-mark question as well, with a look at like the points and the shape. It really depends on the question. But just note that there's no such thing as too much like showing of working out. Like if you show you're working out for your asymptotes and like intercepts, that not only helps you know that you got the right values, but also shows the examiner that you've like gone through the steps. And if they are looking for that extra mark, they will give it to you there. Like it's not always essential. It's like usually look for like shape, intercepts, asymptotes, those things. But showing working out helps you and maybe helps the examiner as well if it's like an extended mark question. So flatly, no, they don't check working out as like part of the graph marking in the VCAR scheme. However, it can be more like relevant in higher marker graphing questions and will also just help you. So I do thoroughly recommend doing working out on your paper to like work out those values and stuff. And how would you go about doing questions you don't understand at all to get some marks, especially the ones with a lot of marks? That is a very good question, especially in like, I feel exam 2, where there's like huge questions worth 16 marks and you just don't know what to do. A tip that you can work out is in some questions, you ask to find out a variable and then use that later on. If you can't find out that variable, just state a value that seems about right, and you will be able to get consequential marks for later parts of the question. So consequential marks meaning that if you get an initial part of the question wrong, they will still give you working out marks for the rest of the question if you still like answer those parts of the question correctly. So tips for like how you do about questions if you don't understand it at all. If you can't find out a variable, just like state a value for it and then keep trying to go through the question. You will get consequential marks that way. If you can't do the first part of the question, but like later down in the question, they give you the answer and then give a few more questions, just go to that part and try and work from there. However, if you don't know how to do a question at all, the best thing you do is just leave it, try and address it at a later stage, going back to it. And by then you may have a new idea, you may have like more consideration about what to do. And just know that if you are stuck on the question, don't panic, don't worry at all. It's completely common, especially in specialist maths, which is one of the hardest sort of content subjects. So if you are stuck, leave the question, come back to it later in a fresh mindset, and you hopefully will get like be better suited to answer that later on. Like, do any of the rest of the panelists have anything else to add on like how you do a solved question that you don't really know how to approach?
I agree with you like completely, so I don't have anything to add.
Oh,
I also agree. The only thing I would add is that if you like have a question and you're just like, damn, I don't know like how to do any of this, just write down some formulas that relate to the topic. At least you've got something on the page, and like Paige said, you can come back and you might have a new idea. But if not, sometimes just writing down the correct formula or the correct like one line to start the working out can actually get you some marks. So like, I guess my personal rule is like, even if I'm really stumped on a question, try to never leave it blank. At least write something, like write a formula that relates to it, or write something. Don't just leave it completely blank, because then that's like zero chance of getting any marks.
Yeah, that's a really good thing to mention. Like, Charles is completely right. Like, I've looked through a few examination reports and they do just give marks for stating a formula or stating the relevant like introductory steps. So definitely try and do what she mentioned there, where try and write something down, if anything, relating to that topic. Special can consist of a lot of very conceptual and abstract problems. What are your recommendations for questions that can seem confusing due to their abstract nature? That is a very good question. Yeah, so specialist is one of those subjects where you have a lot of content. The difficulty comes into play when they try and apply that into really new settings that you've definitely may not have seen before. The recommendations I have for them for those sort of questions is always just come back to the maths. So the maths is what you know, like formulas, rules. So like we mentioned in response to the last question, if there are some really confusing questions that you don't understand the concept of, but you know it's about partial fractions, or you know it's about trig, then maybe just like write down some formulas, write down some introductory steps that tie into those ideas. Obviously, like sometimes it'll just be so abstract that you can't really focus on anything. But if that's the case, again, don't panic. Just read through it as much as you can. Usually they will give you an indication about what like topic they're covering, what area of study they're referring to. So if that's the case, just refer back and think, if this is a really abstract question, but you know it's about partial fractions, then you know, okay, then we'll be trying to separate this at some point. We'll probably be trying to integrate this at some point. So for questions that are very confusing, just know that they all have to link back to your area of study and the content you've learned somehow. They all have to be possible for students to answer in a way. So even no matter how hard they may look, they're designed for students to be able to answer them in some way. As a result, they always should be tying back to what you do know. So if you can write down formulas, laws, stuff like that, that can relate to that general maths topic, that should help you try and address those more abstract questions. As well, the more practice papers, I know we've said that like practice papers, the amount you do isn't everything, but for specialists, it is good to try and expose yourself to a lot of different environments as possible. So after you do like a fair amount of practice papers, you will see a lot of the like environments they put you in. So that's another way to like address that issue of an abstract nature. But just note that regardless, you probably will see something on the day that you've like never seen before. But just note that you always should just fall back on what you know about that area of study, about the formulas and laws that apply into that. And then you should be able to give it the best go that you can. As well, doing practice papers will also introduce you to a lot of those concepts and ideas. Yeah, a lot of really good questions, guys. So with that being said, I'm now going to go back to the content slides and share with you a quick video to enter into the break. So our amazing partners at UBS have prepared some amazing videos here for us today to like introduce us to about a bit about what they do and how they use maths in their own lives. So I'll quickly just play this video for you guys.
Hi, my name's Emma. I work on the equity sales desk at UBS, focusing on hedge funds. My biggest career highlight to date was hosting a panel with over 150 clients who were based around the globe with one of my colleagues a few weeks ago, presenting on one of my pieces of work. At university, I studied commerce with a focus on French, data science, and finance. And in high school, French was one of my favorite subjects. Advice to my younger self would be to make the most of your youth and just ask as many questions as possible, really leveraging the fact that you don't need to know all the answers. All the best with your studies.
Hi, my name's Sahaj and I'm an investment banking analyst here at UBS. So basically, I work with the team to advise our clients on making important decisions, such as how to use their resources most efficiently, how to grow the business moving forward. Is it a good time to sell a part of the business? Is it a good time to maybe buy another business? So we help them with these decisions. What I've particularly enjoyed in my short time here at UBS so far is the opportunity to work for some pretty big companies that I'm sure we'd all deal with on a daily basis. So I think it's really cool to be a part of something like that. So during VCE, I particularly enjoyed math and commerce subjects. So I studied maths methods and specialist maths. And for the commerce subjects, I did accounting and economics. I was really interested by what I learned during VC, so I wanted to pursue it further. And that's why I studied commerce at the University of Melbourne. That's where I learned about finance. I involved myself in a lot of university societies, and that sort of sparked my interest in investment banking and the work that we do here at UBS. Some additional advice from my end is always to be curious and to not settle for things. And whether that's with your career path or what you might want to study in the future, make sure that you're always trying new things and opening your minds to everything that's out there. I guess VC is just one chapter of what can be a pretty long story. So whether you perform exceptionally well or not in a couple of months' time, remember that you still have the rest of that story to write. My advice to myself, if I was doing VC again, would most definitely be to zoom out and always take a look at the bigger picture. You've probably heard something like this before, but high school's a very unique experience, I think. It's definitely one of the last opportunities for you to spend almost every day with a majority of your friends all around you. Make sure not to get so consumed by VC that you forget about what's otherwise a really special year in your lives. Don't forget about your passions, your development as a person. So trust that you've put in all the hard work for your VC exams, give it your best shot, but look forward to the life ahead and everything else that's exciting in your lives.
Awesome. And thank you so much for UBS for helping the revision series be possible, and for all these videos as well, like giving insight into their careers and how they've used maths to improve themselves, and as well as advice for VC as well. So right now I'm going to give you guys a break now, just to get a glass of water, go to the bathroom, and just like have a quick breather before the next content information slides. So until 2:45, you guys have a quick break, and then we'll get started with the rest of the content for today's session. See you guys then. Preparation for exams.
The biggest thing standing between you and what you really want in your life is something that you actually have control over. It's the story that you tell yourself about why you can't have what you want. It's our self-talk. It's when we say stuff to ourselves like, I'm not ready, I should have started sooner, it's too late, I'm not good enough, it's too hard, I don't have what I need, and this is a good one. We'll say stuff like, I don't know where to start, I don't know how to start. You tell yourself a story like that and you pretty much hand over a permission slip to yourself saying, you don't have to do anything. It's literally like your stay in jail card. But here's the deal, and this is the cool thing. This goes back to the beginning where I said it's something you can actually do something about. See, because you're not born with all that negative self-talk. You're not born with that story. That thing evolved through time, but is now so deeply ingrained in your experience of yourself in your life that it feels like it's just who you are. But it is not who you are. The work to do is to manually override that negative self-talk, that story. When you notice yourself in the moment speaking to yourself like that, you'll start to be able to notice that really regularly. It takes practice, right? But if you decide you want to tune into that, you will start to notice and hear that in your head. And what you do when you hear that is you have to, almost like when you hear like your little voice chattering away about you're not ready and it's too late or it's too soon or whatever, pretend like you pick up a phone and talk to your little voice, and your little voice is chattering in your ear, and you just go, no, and you just hang it up. That's what you've got to do. And then you've got to speak to yourself in a completely different way. You got to say stuff like this. You got to say, I'm as ready as I'll ever be. I might not get it fully right, but whatever I don't do right, I'll know to do differently next time. And this one I love, to say it's better done than perfect. If you speak to yourself like that, you get this permission to have a go, to try it out. Because your story is the thing that decides whether you do the things and take the actions that will have you living the life that you love, your best life.
Thank you, Lee, for that video. And actually ties into a lot of the questions you guys have been asking previously about what you do if you find yourself in a situation where you don't know how to do a question or don't know how to respond to something. It's important not to get in your own head and like prevent yourself from actually giving it a go. But just remember that you're always able to give your best effort no matter what the situation you're put in. And therefore, you can always try and get some marks by simply doing your best, doing what you're comfortable with, putting in the formulas and rules that you do know, and try and get marks there. You are, at the same time, your best friend and your worst enemy. It's all really about how you manage, how you're thinking, how confident you're feeling, and how you approach situations, especially specialist maths, where you're very often put in situations you have not seen before, like questions that you've never even thought could be possible, but it all comes back to the same foundation of maths that you're aware of and you're comfortable with. Like I know personally for me, and with a lot of like really high performing students in my school, the issue was always their internal like thinking and like stress and anxiety on the day that really impacted how they performed, not really how much they actually prepared. Because everyone prepares a lot for specialists, everyone works hard, but it's all about the mindset you put in and like how you actually approach doing questions that can really put you over the top. So very good advice from Leah there. But now moving on to the next content part of today's course, which is calculus. So calculus is obviously a very large area of study in this unit. So we will go into a break right after we go through it because there's quite a bit to cover. The stuff to note is like stuff such as implicit differentiation. So for instance, putting like d of x to something which has a y term instead of an x term. U substitution, which is something to make certain integrations easier. Arc length, solids revolution, differential equations, and acceleration. All things we have to be aware of and aware like what ways questions can be like formulated to integrate them into those questions. So we're doing a lot of examples today just to make sure you guys are aware of the different spectra of questions that you may be asked to like answer. First of all, we have the idea of implicit differentiation. So usually when we differentiate, we're only using x terms, and therefore it's easy. We just use the rules that we know. However, we can also differentiate functions and relations that don't only have x terms. For instance, y terms and r as well, and any other variable. In order to differentiate them, we use the chain rule, but differentiate it in order to use it in this new context. For instance, du dx, so differentiating the function u in terms of x, is the same as differentiating it of u in terms of y, multiply it by y in terms of x. For instance, if we try and differentiate y squared, obviously there's no x term there, but what we can do is separate d dx into d dy and dy dx, noting that if we combine those factors together, that cancels down to d dx. We do that because we can differentiate y squared in terms of y. That's just 2y. And then we multiply that by dy dx. And that's the final solution of differentiating y squared in terms of x. Again, the best way to show you guys how this works is to put into practice. So I'm going to do a quite difficult implicit differentiation question. It is worth 5 marks. It was the last question in exam 1. So with that being said, there will be quite a lot of working involved. There's a lot of room for silly mistakes, but it's important to note that all of these sort of questions, you definitely can all do them because they all fall back on the same understanding you've all been taught. It's just about trying to incorporate what you know into new settings such as this. So to respond to this question, we're told to find dy dx at the point root pi on 6, root pi on 3 for the curve defined by the relation sine x squared plus cos y squared equals 3 root 2 pi over xy. And then we're told to give an answer in a very specific form, pi minus a root b over root a times pi plus root b, where a and b are positive integers. So clearly, there's a lot here we have to deal with. We have to give our answer in a very specific form. But when you're asked to do that, just note that 99 out of 100 times, if you just work out the question normally, it will end up in a form very similar to the one they're asking you to give it. And therefore, all you have to do is manipulate at the very end. So don't be scared by the fact they're asking in a very strange form here. After we work this out, let's just see what form we end up with, and then see if we can manipulate it into this form. So to find dy dx, we first have to differentiate this clearly. To do that, let's put everything to d dx first, and then we can solve for dy dx. Because we know there's a y squared term and a y on this side, we can't just do straight dy dx. Instead, we start with doing d dx on both sides. So by what I mean by that is d dx sine of x squared plus cos of y squared equals d dx of the other side as well, of 3 root 2 pi xy. Now, the way we do this is just to go inside this bracket and differentiate each separately. So first of all, it's quite easy to differentiate this. We just take out the differentiation of what's inside, and that becomes 2x cos x squared. For this one, we differentiate as normal, but we have a dy dx left over. So that becomes negative. So cos to sine becomes negative sine. Negative 2y sine y squared. Then we have a dy dx here. Noting to differentiate this, what we did was d dx, d on dy, multiplied by dy dx equals d dx. And that's what we did in this case. And this equals, so differentiating each of these, we have a product rule here. So we have 3 root 2 pi y. So differentiating this here. So if it's a product rule, we do y times the differentiation of 3 root 2 pi of x, which is 3 root 2 pi. And then we also have differentiating y is just 1. So we have 3 root 2, we just have x times the differentiation of y, 1, times d dx, dy dx, times 3 root 2 pi. Let's just simplify this by taking out 3 root 2 pi times y plus x dy dx. Please note again that for this demonstration, we'll be doing as much working as possible just to show you every step. But know that in the exam, as long as you're capable of running through your working, you can do it in less lines as well. You don't need this intermediary step here. I'm just showing you how we simplify it to make ourselves easier for ourselves later on. After we've got this statement, we can now sub in the values for dy dx. So therefore, let's sub in root pi on 6, which is the same as root pi over root 6, and root pi on 3, into this equation where 2x cos of x squared minus 2y sine y squared dy dx equals 3 root 2 pi in brackets y plus x dy dx. So in this case, we have 2 root pi on 6 cos of x squared pi on 6. So the root disappears when it's x squared, minus 2y, so minus 2 root pi on 3, sine y squared, so root pi on 3 squared is just, of course, pi on 3. And of course, you can cut out this step. Usually just go straight to what these actually equal, but I'm just showing you how we get to next step by showing this intermediary line. Dy dx equals 3 root 2 pi in brackets y, which is root pi on 3, plus x root pi on 6 dy dx. After we do this, what we have to do is obviously try and isolate for dy dx. The first thing we can do is get rid of all these trig like values here. So 2 times root pi on 6 cos pi on 6. Cos pi of 6 just equals root 3 on 2. So therefore we can write this as just, if that's root 3 on 2 times root pi on 6, that just results in root pi on 2. Next we have sine pi on 3, which again is just root 3 over 2 times 2 times root pi on 3, and that just equals root pi, leaving over dy dx. This equals 3 root 2 pi in brackets, this again. Noting in this case, however, we can try and bring these in and then separate them out. So for instance, let's take out, if this is 3 root 2 pi, we can make this as well into another form. We can make this into the form. If we take out pi and bring in these values, 1 pi, 18 pi on 3, plus 1 pi times 18 pi on 6 dy dx root. I want to be clear like what we did there, because that was the step that a lot of students missed in terms of trying to take these out. So in this case, we're trying to bring in 3 root 2 pi into this equation. We do that by timesing that into it. Noting, however, that 3 root 2 can be brought into this by making 3 root 2 equaling 18. So 3 root 2 equals root 18. So that's what we bring into each of these. So that becomes 18 pi over 3. That becomes 18 pi over 6. And after that, we can simplify this even further. And therefore, we can state root pi on 2 minus root pi dy dx equals, this is the case, you can bring pi in here. If that's pi and that's root pi, this just becomes root 6 over root pi plus, same case here, root 3 over root pi dy dx. Noting that we do that again by taking out the root pi here, dividing root pi from both sides. It has root pi as denominator for each of these. And then obviously it's cancelling. 18 divided by 3 is 6. 18 divided by 6 is 3. And now we get this, and we can finally get the step of actually isolating for dy dx. So therefore, if we bring the like terms to one side, we have dy dx in brackets, root 3 over root pi. You bring this to this side, so that becomes plus root pi equals, on the other side, root pi on 2 minus root 6 on pi. And then we can finally start bringing everything together and bring all under one fraction. So therefore, this is the same as dy dx of, if this is pi, root 3 plus pi over root pi equals, bring these together as well. So if this is over root 2, this is over root pi, multiply this by root pi, so we have pi, multiply this by root 2, therefore we have 2, 3 over root 2 pi. And therefore, we finally will end off by putting this all together. So if we divide, we're pretty much doing pi minus 2 root 3 over root 2 pi, multiplied by the reciprocal of this, pi plus root 3. We can cut, this is root 2 on the bottom, equals therefore pi minus 2 root 3 over root 2 times x plus root 3. So clearly, it is a quite long question in terms of working out, but that makes sense. It is the very last question in the exam, so a lot of working has to go into it. But let's just check we have it in the right form they're wanting it. So we're asked to give the answer in the form pi minus a root b over root a times pi plus root b, where a and b are positive. Let's just check this. We have pi minus 2 root 3. A is positive. It's negative a, negative a positive number. It's negative. And we have b is positive as well, obviously, because under the square root. So that's the answer to that question. So clearly a lot of steps involved, a lot of working out involved. Remember, again, we did do a bit of overworking in this case to show every step. A few of these lines can be cut out of the actual final working out. But note that for a 5-marker like this, they are looking for quite a bit of working out. So it's good to show every line as much as you need to ensure you get the right answer in the end. But yeah, that's a very, not standard at all, actually, quite a difficult question. But again, noting that it all falls back to the same ideas that easy questions have. For instance, we're just doing d of dx of both sides, doing implicit diff, isolating for dy dx, substituting in the values that we need. So again, it can be formulaic if you're able to make it so by like recognizing the steps involved. With that being said, we can now jump to the next sort of content part for this, which is U substitution. So very commonly, especially with trig integrations, it can be very hard to work out how we integrate certain functions. The way we find out how to integrate harder functions is by using a tool called U substitution. This is when we make a substitution for a value and evaluate an integral we may have otherwise not known about by using that substitution. The best way to revise is just to jump right in, and therefore I'll do a question for you guys showing how to actually implement it. But please note, don't rush a substitution. There are many places for mistakes to occur. U substitution is a very commonly tested skill in specialist. With that being said, it can be a bit finicky with likely many steps going into it, and therefore it's important to be careful exactly how you choose to implement the strategy. So with that being said, I'll do a question for you guys now. So asked to evaluate a 3-mark question, evaluate 3 pi and 4 pi and 2 as the upper and outer bounds of cos squared 2 of x times sine 2 of x dx. So the general rule is, if you have cos and it's an even, sine has no real power. If cos is an even power, you usually let that be the substitution. So for this case, let u equal cos 2x dx. The reason is because, as we know, when we differentiate a cos function, we have a sine, and we already have the differentiation there. So I'm sure you guys have done U substitution in the past, but I think it is also good to know that for your bound book, something you may want to have is just like a list of when you use which substitution, because this is a common sort of substitution question. And something that happens is, for instance, if you have, for instance, cos to the power of 3, when do you use u as a substitution? If you have cos 3 sine squared, when do you use substitution? Which do you actually substitute in? There are a lot of different cases. The textbook does a very good job of explaining when you substitute in which trig formula, but just know that's something that could be helpful for you guys. But if we let u in this case equal cos 2x, we know, let's write out some other things we know then. We know that du dx equals -2 sine of 2x. And we know, therefore, sine of 2x equals -1/2 du dx. So the trick here is, the way U substitution works is we're letting a value equal u, knowing that dy dx is the same as doing du dx multiplied by by doing, in this case, the basis of U substitution is this general equation, dy of du times du dx. So this is how U substitutions work. This is the general sort of principle. So we're inserting a new variable into this, u, knowing that if we differentiate u normally, we can then multiply that by du dx, and that will give us the original dy dx. That's why it's important to work out if we actually have du dx in this equation. If we don't, we can't actually do u sub. But if we don't explicitly, we can manipulate it by working out, okay, we have sine 2x, that equals negative half du dx, and therefore we can get down to dy dx by just substituting in this. To show you what that means, let's just do this question as it is. So therefore, we have pi on 2. We have 3 pi on 4 as the bounds. We have cos squared of 2x. We have sine of 2x dx. And now that we've done all this prep, we can satisfactorily just input all of these in. Therefore, this just equals cos. If u is cos 2x, the way we work out the new bounds is just putting these values into the function we have here. So therefore, this upper bound is cos 2 times 3 pi on 4. So cos 3 pi on 2. This lower bound is cos 2 times pi on 2. So cos pi. Then we insert in sine 2x equals negative half du dx. Cos squared 2x equals u squared. And we still have dx. And then from this, du dx cancels out. And then we're left with cos 3 pi on 2. That just equals 0. If you think of the unit circle, 3 pi on 2 goes here. The x value is 0. Cos of pi is to there. That's negative 1. The du dx and dx cancel out. We're left with negative half u squared du. And then we evaluate this. We have integrating this. We have negative 1/6 u cubed. Differentiating this, bring the 3 down, that becomes a negative half u squared. Then we have 0, negative 1. And from this, we go, we'll actually go here. From this, 0 inserted into this is nothing. If we put negative 1 into this, it becomes negative 1 times negative 1/6, minusing that is just negative 1/6. So therefore, we can say this is equals negative 1/6. So quite a bit of working, but it's important to note that specialist study is quite common. You will be quite rushed in these sort of exams, but it's important to always come back to the fundamentals. And after doing that, you can see how these sort of questions play out. Another important thing to note in regards to calculus and specialist is the idea of arc length. So arc length is a very common question, as well as volumes of solids revolution. But just note that for both of these variants, it all just comes back to the laws that you know, the very explicit laws that are given to you. These appear on the back of your formula sheet as well. But just note again that you should be kind of memorizing these anyway, because that will really help with these sort of questions in this process. So firstly, let's look at arc length. This first one is given when it's just a normal function. So working out the length of an arc of a function, just do from which value of x to which value of x, root 1 plus the differentiation of x squared. However, when it's given to us in parametric form, we do the same thing, but do the squares of each, x dash and y dash. I'll show you what I mean in this question that we do. Noting that, of course, parametric is making it a bit harder. So it's asking us to first write down the definite integral in terms of theta that gives the arc length from theta equals 0 to theta equals pi for the curve defined parametrically by x equals cos 2 theta minus 3, y equals sine 2 theta plus 1. So if we just use the formula we know, we can quite easily write this equation. So we go from bound to bound, theta equals 0 to theta equals pi. And then we have under root dx dt squared plus not t in this case, theta, d theta squared over d theta squared d theta, that equals the length. And all we have to do after that is just insert these values in, and therefore we get a definite integral. Let's quickly differentiate these. If we differentiate this, this becomes negative 2 sine 2 theta. And this becomes 2 cos 2 theta. And therefore, we can just write length quite easily as length equals 0 pi root 4 sine squared 2 theta, squaring this, which is obviously negative 2 times negative 2 is 4, plus 4 cos squared theta d theta, which you can also simplify down to being, if the law is sine squared plus cos squared equals 0, therefore we can take 4 out, and this becomes pi 0 root 4 is just 2 d theta. Therefore, length equals, if we just solve this, then we have 2 theta pi 0, and that just, of course, equals 2 pi units. So in this case, a classic arc length question is question 8, a 4-marker. Working is necessary. The first question is asking us to write down definite integral. We gave that in terms of theta. We gave that in multiple steps. This is still correct in terms of theta because it's in terms of theta here, even though there's no theta term right there. But we worked it out here anyway. We'll definitely get the mark. And then working at the length, we've given it, and we've also written units. It hasn't given us the units, but we have to write that just in case we're looking for the extra differentiating factor. So make sure we have the units for any length area sort of question. If there's no units given to you, no like meters squared or anything, just write units and that's fine. Additionally, we also have solids of revolution as another common calculus question. Again, it all just comes back to the same theory, the same sort of laws that we have already. So in this case, we're trying to find the volume of the solid of revolution formed from the graph of y equals root 1 plus 2x over 1 plus x squared is rotated about the x-axis over the interval 0, 1. So please note that you should definitely know what solids of revolution questions look like. You should definitely know what arc length questions look like. These are like just straight content points that are very relevant for you guys to know, and that's what we're covering in today's session. So for a solid revolution question like this, you just note it's rotated about the x-axis, so you use the x-axis formula, which is pi b a as your poles, y squared dx for volume. If it was around the y-axis, you use the other formula instead. And therefore, for this, after you've worked out what the formula is, you just input the values. So it becomes quite simple. So pi b in this case, sorry, I covered over b. In this case, is just 1. Yeah, b is 1. A is 0. And y squared is just this squared. So 1 plus 2x over 1 plus x squared d of x. We can separate this out to make it easy for ourselves. So pi 1, 0 of 1 on 1 plus x squared dx plus pi 1, 0 of 2x on 1 plus x squared. Then we just integrate this. This first one's quite easy. It's just, as you know, the tan law is this tan inverse. Again, the inverse trig functions for integrals are also on your formula sheet if you forget them. But just note for this one, if it's like 1 on a plus x squared, that equals tan negative 1 x on a. X on a. And as well, in this one, we have, also, of course, have to have the bounds. For 2x over 1 plus x squared, you just have, log e. Yeah, differentiation of 1 plus x squared is 2x, and therefore you just write it as log. One, 0, and therefore you solve from that. So tan inverse of x equaling 1, that equals pi on 4, so pi squared on 4. Tan inverse of 0 is 0, so there's nothing there. Plus log e 1 plus 1 squared is log e2, so pi log e2. And log e of 1 plus 0 squared is just 0, so there's nothing there. And therefore, this is the units. This is the result, and we write units afterwards. Units cubed, because it's volume. It's quite a straightforward question, just showing lines are working to get the working marks. Again, noting that whilst it may look a bit weird, this like sort of format of the function, note that all you have to do is rely on your basic knowledge of how you do volume of solids revolution questions. What you do is find the formula, input the function, and solve. In this case, the hard part was just separating these functions out. That conceptually may be a bit difficult, but noting after that, it becomes quite straightforward in how we approach it. And that's a general overview of like all the stuff we really need to know about this general calculus stuff in terms of revolution, in terms of arc length, all that. Additionally, something else we probably need to cover as well is the idea of, so we've done a few questions on these, differential equations. So last thing we'll cover in regards to calculus and stuff is differential equations. For the sake of time, I'll not be working through all the theory and stuff, there's quite a bit on it, but I'll just show you the worked example of how you apply the formulas for these. So noting that the formulas for these are also on your formula sheet, but again, you should be more like prepared to just know how these appear in different cases, in different environments, and different problems, and that'll help you much more than just like relying on the formula sheet for everything there. So I'll do a differential equation question for you now then. So it's 10 marker, so quite a long one, but again, a very common sort of question to test your knowledge of how to do differential equations. So solve differential equation, root 2 minus x squared dy dx equals 1 over 2 minus y, given that y of 1 equals 0. Express y as a function of x. To do that, what we do is just quickly do initially separating this out in order to get dy on the side of the y values and x on the side of the x values. So therefore we have 2 minus y, multiplying this to this side, 2 minus y dy equals times both sides by dx, divide both sides by root 2 minus x squared. You get 1 on root 2 minus x squared dx. Noting that this is just an example of the inverse sign, where sine inverse of x on a equals 1 on root a squared minus x squared. So with that being the case, we can then write both of these as integrals. So integral both sides, so 2 minus y dy equals integral of 1 root, well, this is of course integral, 2 minus x squared dx. Therefore, we have 2y minus y squared on this side equals, if this is a sine inverse, just sine inverse. A in this case, a squared is equal to 2, therefore a is just root 2. The sine inverse is x over root 2. And then from that, we also have to have, additionally, some momentum, some constant term as well, added from both sides. Let's call it c. So if that's the case, after we do that, we input the information we're given to work out what c is. So when x equals 1, y equals 0, therefore 0 times 2 minus 0 squared is 0. X equals 1, so sine inverse of 1 on root 2 plus c. This is, of course, just pi on 4, and therefore c equals negative pi on 4. Therefore, we have 2y minus y squared on 2 equals inverse sine of 1 over root 2 minus pi on 4. To solve the equation, we have to give it in terms of x equaling y, and therefore at this stage, we just need to work out how to isolate y. So let's bring y squared to one side to make it positive. So therefore we multiply everything by 2 first to get this 2. We have 4y minus y squared equals 2 sine inverse plus pi on 2 minus pi on 2. Let's bring the y squared to one side. So we have y squared minus 4y. So multiplying both sides by negative 2 pretty much equals negative 2 sine inverse 1 on root 2 plus pi on 2. To get rid of the square, we have to complete the square in this case. So therefore, y squared minus 4y. To complete the square, we add and subtract b squared on 4. So b squared in this case is 4 squared, 16, divided by 4 is 4. So we plus and minus 4 to get this. We complete the square. And then, so completing the square gives us y minus 2 squared. Let's complete the square. And then after this, let's root both sides. To get y minus 2 equals negative, or plus or minus actually, root negative 2 sine inverse x on root 2. Sorry, 1 on root 2. X on root 2. Get my ways out. X on root 2. And there should be an x as well throughout. X on root 2 plus pi on 4, pi on 2. Next, the important step and the one that catches most students out is whether or not we take the positive or whether or not we take the negative of this. So initially, we have to work out what actually is the parameters of this. Let's consider the actual function. When x equals 1 and y equals 0, we consider it has to be actually negative because under this bracket, so under the bracket 2 minus x squared, we have to consider when this root actually exists. So when x equals 1, y equals 0, we're told that this function has to exist, and therefore this has to be a defined value. If that's the case, if we go down here, if y equals 0, then we have negative 2 on this side. We have negative 2 sine inverse 1 on root 2 plus pi on 2. Therefore, negative 2 equals plus or minus this. Because the root of something is always positive, the root of anything is positive, and this is a negative, we have to have a negative outside in order for this to equal 2. What I mean by that again, if we're solving this, we're told that one of the points is 0 and 1. If we put 0 and 1 into this equation, we have y equaling 1, or y equaling some value. Let's say this is now, if that's 1, this actually is negative 1. This is a negative value. The root of this has to be positive. In order to get it as negative 1, we therefore have to have a negative in front of this bracket, of this root. And that's why we say it has to be negative in order to get a negative value out here. So if we therefore reject the positive, stating that, of course, let's say reject positive because 2 minus some value equals 0 when x equals 1. We can therefore finish this off by actually writing out equation y equals 2 minus this fraction, this big root. So again, it's a lot of steps. I understand that. It is the last question in exam 1, so therefore it's designed to be particularly difficult and challenging. But the same process applies. We supply our knowledge differential equations. We put an integral on both sides. We input the value that we know. We work out c, and then we slowly work our way down to isolate y. The question is asked us to solve the equation in terms of x. We've done that. Y equals some amount of x, and that is the answer there. There are a few steps involved, long process, but that's a solved question you will be expecting to see later on. Additionally, just note that these solved questions, when it's a 5-marker, you will be expected to show quite a bit of working out. And therefore, it's important for you to try and be aware that the more working out you give, the more chance you'll get of getting all 5 marks, as well, the easier it is for you guys to understand what is going on. I'll end off to the calculus section with a bit about acceleration. So there are a lot of acceleration formulas given to you in the textbook. The one we'll be using today, for instance, is acceleration is v dv dx, velocity times differentiation of velocity over x. Note that there are quite a few formulas that may be used. It's about being able to maneuver around and use the right one for that circumstance. That will be able to help you in that regard. So, for instance, the acceleration a in this question of a body moving a straight line in terms of velocity is given by a equals 4v squared. Given that v equals e when x equals 1, where x is displacement of the body in meters, find the velocity of the body when x equals 2. So let's firstly go back to what we know and go back to the formulas that we know. So we're given a equals 4v squared. We know the formula is a equals velocity times dv dx. Therefore, let's find that out. Velocity times dv dx. Again, that formula is given to you on your bound reference in the formula sheet, but it's good to know all different formulas that can be used. This equals 4v squared. Therefore, isolating for dv, we have 1 divide both sides by 4v squared, 1 over 4v dv equals 1 dx, or just dx. Integral both sides, 1 4v dv equals integral of 1 dx. Therefore, the integral of a fraction like this is a log, so 1/4 of log e of v, log e of v, where if we differentiate this, it becomes 1 over v, then 1 over v times 1 over 4, which is 1 over 4v, equals x plus c. Next, we go back to the actual point that we were given. We were given v equals e when x equals 1. Therefore, to work that out, we have 1/4 to substitute in these values. Let's just say when v equals e, x equals 1, and therefore 1/4 log e of e equals 1 plus c. Therefore, if log e of e is just 1, therefore 1/4 equals 1 plus c. Therefore, c equals negative 3 on 4. Therefore, we have the equation equals x minus 3 on 4. Therefore, when x equals 2, the question is asking us to find velocity when x equals 2. We've now worked out an equation in terms of velocity and x. When x equals 2, 1/4 log e of v equals 2 minus 3 on 4, which is 8 on 4 minus 3 on 4, is 5 on 4. Divide both sides by a quarter. Log e of v equals 5. And therefore, velocity equals e5 meters squared. Not meters per second. Not squared for velocity. Make sure and give the unit and make sure we get the right answer there in terms of velocity. And that's another example of a different question that can appear, in this case when using the idea of acceleration. So as we can see, there are a lot of different applications of calculus that are experimented with in specialists. It's important just to be aware of all the different forms they come in and just be aware of how you just pretty much always fall back on the formulas, rules that you know, and no matter how difficult the question is, you can therefore try and interact with it and do the best you can by using what you know to answer them. So with that being said, I'll now do a few questions, knowing that we need a bit of time to break after as well. So returning back to the Mentimeter to answer a few of your questions. When I was doing practice exams, I realized some MCQs took over half a page of worth of working out to complete. Is it worth just skipping MCQs? So the advice that I was given, which I thought was quite good, was that in the actual exam, you probably want to do extended response first, because then it's very easy to guess MCQs. You have 1/4 chance of getting it right, but you can't really guess extended response. So I think if you're doing MCQs first, I think it's very important to be aware of the time factor involved in doing extended response. That's why reading time is so important. You can plan out, okay, it'll take a long time to do extended response, and therefore I should dedicate more time to it. However, skipping MCQs, yes, if you're stuck in a question, just always skip it and move on, and then like mark it to do later. But just note that skipping MCQs that take a long amount of time is a smart strategy. Even better, perhaps, is starting off with extended response, and therefore you leave yourself with time that you have left over to do MCQs, which you can either do quickly or slowly, depending on how much time you have. It really depends on how you choose to do exams, but it isn't really worth to like lose easy marks. But at the same time, I know what you mean. It's definitely important to prioritize where you think you can get more marks more easily. Can we write CAS commands in our working out? No, you cannot write CAS commands in your working out. You can't like write menu 3.1, this or something like that. You have to write literally what you type into the CAS, pretty much what you would do like on paper without the actual like commands. So if you're solving for f of x, you literally write f of x equals this, therefore x equals. You can't, definitely don't write CAS commands out, but you still write down what your CAS is doing as you're working out to like solve that issue there. Should we do extended response? Oh, okay, so depends on what you've done. Don't change your style now. If you've always been doing MCQs first, then you should probably keep doing that. I don't recommend changing your entire style. Just note that if you're still like tossing turving which one to do, I recommend doing extended response first and getting it out of the way, because it's much easier to guess multiple choice if you instead of doing extended response. However, again, depends on what is best for you. See which helps you the most and which helps you get to the exam the easiest. What do you recommend for the bound book? I'll do one more question now before I go to the break stuff. The bound book. I'm not sure what the rest of the panelists think, but for me personally, I found that writing in questions I got wrong in the past was really good, like writing in the hardest questions. So if you see something similar in the exam, you can just flick to that. Definitely don't try and prioritize always using a bound book during the exam, because that takes up a lot of time, takes a lot of like, makes it way less efficient to answer the question. But I recommend putting in notes and formulas that you know you'll use, putting in like weird trig formulas or weird cases of certain questions. Therefore, if you see a question in the exam, be like, that's a really weird question, but I've done something similar in the past. You can, for instance, look back at that question and may help you out. Do any of the other panelists have any ideas about what you should do in the bound book instead?
I would also recommend putting in your CAS like shortcuts in case you forget how to get to a certain function, etc. But yeah, as Paige said, really try to keep your bound book small, because if it's really big, you're going to be tempted to just spend time looking over stuff when you should just be spending time working on the exam in front of you instead of trying to, reconcile it or even check if you're correct. So that's the whole point of preparing for the exam, right? So that you're confident enough to go in to not have to check every single decision you're making in your bound book. It should really just be there as kind of like a backup. I think most people I know didn't even really end up using their bound book, because in making it, you study the content so well that you don't even need to go back and look at the things that you did put in your bound book. So yeah, just really keep it to things that you think you won't be able to remember by yourself, and just maybe a couple generic formulas, etc. if you're scared that maybe in the pressure of the situation, you might forget it.
Yeah, definitely. And on top of that, I'd like to also add a caveat to what I said before. In regards to what you do first, like extended response or multiple choice, it is completely up to you. I know a lot of students prefer doing multiple choice questions first, because for instance, that gets you guaranteed marks because they're a bit easier to do usually. But it's completely up to what is best for you and what is like good for you in terms of how you do exams. So after do a few practice exams and try both styles. For some people, doing extended response is better. For some, multiple choice is better. It really depends on what you want in terms of exam. So the best indicator and the best person to tell you that is probably yourself. But there are definitely benefits and cons to doing both in either order. With that being said, we'll now definitely move into a break after all that calculus stuff. But before that, we have another UBS video just to go over some of the ways they've implemented their studies into their career paths.
Hi everyone, my name is Ben Crofts and I'm an investment banking analyst here at UBS Melbourne. I think the way that I describe what I do is I'm effectively a real estate agent, only instead of selling property, I'm helping to facilitate the sale and purchase of businesses. I think career highlight so far has been the opportunity to work with so many like-minded and intelligent people, as well as being able to support UBS's recruitment program, which I found to be really rewarding. Prior to studying at UBS, I completed my Bachelor of Commerce degree at the University of Melbourne. Whilst there, I majored in finance and particularly enjoyed investments, corporate finance, and derivatives. Obviously, prior to that, I completed high school here in Victoria and completed my VCE. Whilst in high school, I particularly enjoyed mathematics. I actually did specialist methods and further, which was quite unusual at the time. And also obviously did English, also did physics and accounting. But I think if I had to choose a subject from memory that I enjoyed the most, it was probably specialist maths. So I think I might reframe this question slightly to be advice for my former self rather than my future self. So if I was able to advise my former self on anything, it would be to get involved as much as possible at university. Uni is really one of those things where you get out what you put in. So I'd recommend that my former self get involved in as many clubs, groups, societies, and events as possible. It'll really stand you in good stead. So if I were advising myself a few weeks out from my Year 12 exams, I think I'd just tell myself to relax. You know, you've done the hard work up until this point. You've worked very, very hard with your teachers and your classmates to ensure that you're prepared for this upcoming sort of exam period. And now is just an opportunity to demonstrate what you've learned. The entire process is over in the blink of an eye, and before you know it, it's holidays, and then you're in uni, and then before you know it, you'll be in the workforce. So try to make the most of the time, enjoy of it what you can, and look at it as an opportunity more than anything.
Thank you, Ben, for that video as well. So right before we get into the last little bit I'll be presenting today, a just quick opportunity for you guys to have a quick break. So let's say at 3:45, we'll get back and ready to go for the next part of the content. But for now, get a glass of water, stretch your limbs, and get ready to go for another little bit of content in 5 minutes. See you guys then. Okay, we may get back underway with the rest of it, but right before we get back into the last little bit of content I'll be presenting, I'm sure you guys must be quite sick of my voice at this point. So to kind of break up that, here's another video from the amazing Leah Davidson, as well, just to help you for studying and preparing for like exams and assessments, stuff like that.
I've always thought about someone talking to themselves as being like a sign that they're kind of crazy. But the truth is that we all talk to ourselves like constantly. Like we have an inner chatterbox, a little voice. It lives in this part of your brain that's constantly going. Like it's constantly giving us advice and editing what we are thinking and what we should do and what everyone else is doing. Like that's always happening in our heads. So I've got an awesome idea. Like if you can decide what that chatter is in your head, oh my God, I promise you life will look totally different. And it really is. It's a matter of owning the fact that we do this self-talk anyway. Go, yeah, lean into that, I do that, and to tailor it in a way that actually really supports you instead of holds you back. Because the thing is that we are hardwired to be in constant self-protection mode. So that little voice in our head is constantly trying to keep us from failing, constantly telling us, don't do that, you'll look stupid, don't try that, you've never done it before, you should have all your ducks in a row before you even attempt that, which pretty much, like, this is probably the single biggest reason why people don't achieve their goals. It's probably the biggest reason why people don't even set the goals that would have them feel the happiest, because the fear of failing is so huge, and that little voice in our head is going, you're not quite ready. So here's the thing to try and practice, because it is a matter of practice. You know, it's a matter of starting here and practicing it and building your muscle around this. Here's the thing to try. When you find yourself thinking to yourself, man, I'm not ready, I need to do this before I could ever possibly do that, I should be more prepared, blah, blah, blah. All the stuff we say to ourselves that keeps us from actually doing the first step of what we want to do. Instead of saying that, just try it, practice, go, look, I don't have everything sorted out. I feel excited in some ways to try it. I'm going to try it. I could fail. I could look silly doing it. But it's one step towards me following my dream. And that bigger picture makes anything worth it. It's hard, like it's totally hard. It'll trigger lots of stuff in you. But the thing is that it will be the thing that has you grow and progress. And without growth and progress, like we actually feel like it's probably, you know, it's one of those things that makes us feel the least alive when we're just stuck and we're not making any traction in the stuff that's important to us. I really hope this helps. I would love to hear any questions, thoughts, comments. See ya.
Thanks so much, Lee, for that video. Additionally, if you want to find out more information and book exam hack sessions with Leah, please look in the chat now and Nan sent out the link for all of that.
I've always thought of...
To end my little spiel for today, I'll be going over the last two areas of study that I'm covering, which is on vectors and then on mechanics as well. So for vectors, the first important thing to note, which you guys have definitely done so much work on, is the idea of the vector resolute. However, despite the amount of times it comes up, a lot of people still have trouble with it. The main formula you have to know, and the one that you always have to use, is just this. The vector resolute, u, of A in the direction of B is just A dot B over B dot B times B. It's the same as just A times the unit vector of B times the unit vector of B. So the best way to show how that comes into play is to do a question. So I hope you guys know already what the vector resolute kind of shows conceptually. So conceptually, let's say we have a vector A and we have a vector B. The vector resolute of A in the direction B is the vector, is some part of vector B that lines up with A, like this, where the distance between the two is the shortest distance between the two vectors A and B. And that's what we actually try to find. To find that, we just state the vector resolute is just, again, A dot the unit vector of B times the unit vector of B. That's the formula for the vector resolute. Let's just work out what the unit vector of B is so we can actually work this out. So the unit vector, also known as like B hat, equals 1 over the distance of B, the magnitude of B being just each value in front of I, j, k squared under a square root. So 1 squared plus -2 squared plus 3 squared for B. So again, this will give us the unit vector of B, and multiply this by B, which is just I minus 2j plus 3k. The question is asking us to find the vector resolute of A in the direction of B. We use B hat often in that formula, so it's easy just to find out B hat first and then put that in. So therefore, B hat equals 1 over 1 plus 4 is 5 plus 9 is 14 equals, if that's 1 on root 14, it's just 1 on root 14i minus 2 on root 14j plus 3 over root 14k. Now, after we do that, we can put this into the formula for vector resolute. So what is A dot B? The dot product is just multiplying the I values together, j values together, k values together. So if A has 3i, therefore this is just 3 on root 14. A has 5j, so 5 times -2 on 14 is just -10 on root 14. -2k, so minus 6 on root 14. And then by B hat, this is just -10 on root 14. So therefore, if we just multiply this by whatever B hat was, So if this is, sorry, minus 13 on root 14, therefore this equals minus 13 on root 14 times this is just negative 13 on 14i plus 26 on 14j, which we can simplify, of course. 26 on 14j is the same as 13 on 7j. And then 13 on 14 times this is just minus 39 on 14k. So note, vector resolute questions are extremely formulaic in how you do them. It has a very set formula. All you have to really work out is what b hat is. That you do by finding b divided by the root of the magnitude. After you find b hat, just insert that into the formula, and that's how you work out that sort of question. It's a very common one, but very good to cover that in case it comes across in the exam. Additionally, we have the idea of linear independence. So in this case, a set of vectors is said to be linearly independent if you cannot express one vector using the others. For example, the set I plus j, 2i minus j, since we can write it as, we can write I plus j as a combination of the other two vectors, therefore is linearly independent. It's not linearly independent because we can't do that. So the way to prove if something is linearly independent is if you can make one by, if you can't make one by combining the other two vectors together. So therefore, it's the same for the inverse. If you want to prove something is linearly dependent, you do that by showing one vector is equal to the combination of two other vectors. So again, a question to show you how that comes into practice. So find the value of d for which the vectors a equals this, b equals this, and c equals this are linearly dependent. Okay, so the vectors are linearly dependent if c equals some amount of a plus some amount of b. Let's call it ma plus some nb. So vector c is, this is all linearly dependent if c can be made by adding some amount of a to some amount of b. It's a combination of those two vectors. Therefore, ma plus nb equals, so let's expand this out, m times a is just 2mi minus 3mj plus 4mk minus 2ni plus 4nj minus 6 minus 8, sorry, 8nk. Noting I'm going to do every line of working pretty much just to show you the steps, but note you can make it much more efficient by cutting out a few steps like this. But it's a 3 marker, so you do have to show some amount of working. Next step is to isolate for the i's. So therefore, ma plus nb, let's group the i's, 2m minus 2ni plus 4n minus 2n minus 3m, sorry, j. And the k's we have plus 4m minus 8nk. And this is told to us as equaling c, equaling this vector here. Therefore, the question ends like quite simply pretty much by just making simultaneous equations. So therefore, 2m minus 2n equals negative 6, or just divide everything by 2. M minus n equals negative 3. The negative 6 comes from the I value of c. So just equating pretty much the I values on both sides. Let's call that equation 1. Equation 2, let's look at the j's. So 4n minus 3m equals 2. Let's call that equation 2. Then equation 3, look at the k's. So 4m minus 8n equals d. So that's the value trying to work out. Well, from this first one, we have m equals n minus 3. Let's insert this into this equation here. So therefore, 4m equals 4n, sorry, minus 3n, because it's 3m, plus 9 equals 2. Sorry, 3m. Yep, plus 9 equals 2. And therefore, we have 9 equals 2m and minus 1 equals negative 3. Therefore, we get m equals negative minus 3. I'll probably add one more step to show how we actually expand this bracket. So if we have 4n minus 3n equals 2, we then have 4n minus 3m minus 3 equals 2. And therefore, n equals 9, 7 minus 7. Therefore, m equals minus 10. If that's the case, if you have those values, input those into here. So 4m, negative 40, minus 8n, so minus negative 7 is minus negative 7 is just plus 56 equals d. And therefore, d equals 16. That's the value for these factors to be dependent. So again, independence, dependence, they're quite simple concepts. It's dependent if you can form one vector by adding the other two vectors together in some degree. And you usually always just use this formula here. Vector C equals sum of A to sum of B. Additionally, another aspect of vectors is vector calculus. So just like we did calculus before with like x's and y's, we can do it with the terms of vectors as well. So all we need to do is just like realize vector calculus is just doing the exact same thing we do with x's and y's, but instead in front of i's and j's instead. There are a lot of easy questions to cover that idea, but to show you how like specialists can push this idea to the max, let's go into kind of a very difficult example of vector calculus. So we're looking at another question 10. So another difficult question, but one that is quite common in how it's expressed. The position vector of a particle moving along a curve at time t seconds is given by r of t equals t cubed over 3i plus inverse sine t plus t root 1 minus t squared for t is between 0 and 1. The distance d meters that the particle travels along the curve in 3/4 of a second is given by this. Find the ABC, where ABC is just the root of z. So the way we do this is by working out the arc length. Remember the arc length formula was just root dx dt squared plus root plus dy dt squared. This is t2, t1. The only difference here is that we're giving it in terms of I and j, but I just equals x and y just equals j. So therefore, x of t equals t cubed on 3. Therefore, dx dt equals t squared. Y of t equals t times 1 minus t squared. And therefore, dy dt, you just do the product rule. So product rule of that is just derivative of t times 1 minus t squared, so 1 minus t squared. I'll actually probably just do it in the lines. So what is dy dt? Dy dt, the product rule, so 1 minus t squared, and then you do t times the derivative of root 1 minus t squared. To do that, you do t plus t times, you take out 1 minus t squared, 1 minus t squared. So for this function, it's the same as doing the derivative of 1 minus t squared 1/2. The derivative of this, you just bring down a half, obviously. You bring out the negative 2t from inside. And then you're left with 1 minus t squared to negative 1/2. So this power minus 1. So all this goes to show this is equals. So root 1 minus t squared plus, to put this all together, this cancels out, becomes negative t over root of this, and then we're left with negative t squared. So therefore we have minus t squared over root 1 minus t squared. So again, we have to bring these two things together. So that was not in there. And then we bring these two things together by multiplying top and bottom of this one by root 1 minus t squared. Then we're left with 2 minus 2t squared over root 1 minus t squared. And then from here, we can just leave that like this. 2, 1 minus t squared. Take out the 2 here. We have 2, 1 minus t squared. And cut, we have this. So quite a bit of working to work out what y dt equals, but that just results in this. And after working out those values, we just input that into the actual formula. So therefore, the distance t1, t2, so 3, 4, 0 of root dx dt squared, so that's t to the power 4, dy dt squared, so this squared is just 4 minus 4t squared, and then that is dt. We're asked to give that in the form of d like this, and to do that, we just do d equals 3 on 4, 0 of root t squared minus 2 squared. And therefore we have that. As a result, additionally noting that when we have take it out of the root, so we have d equals therefore 0, 3 on 4 out here, we have plus and minus t squared minus 2. But remember again that we have a domain here of 0, t1, t is positive, t is between that. For that to be positive, under this bracket, under this root, t has to be between them, and therefore this has to be a positive value as well. Therefore, we take the positive. So therefore, d just equals 3, 4, 0 of 2 minus t squared dt. So again, just noting that because the domain of t is between 0 and 1, we therefore have to work out what this equals. Again, because it's that, we want the positive distance for the distance to be positive. And because we know it's between there, if we minus 2 minus t squared, that will always be positive. But if it was t squared minus 2, that won't be positive when t is between 0 and 1. And that's why we have to take negative. And that is pretty much all we need to cover the vector in that case. So just being conscious of time, I may now pass it over to Chelsea to go through the probability aspect of the course, because that was something that was removed from last year's syllabus, but is back here. So I'll pass over to Chelsea for this part of the course.
Cool, thank you for that. So I'll start sharing my screen. Also give everyone a chance to just have a little stretch now, drink some water, wake yourself up. Because I know it's been a long session, but thank you everyone for staying here. Cool, so I should be able to see my screen now. Alrighty, so what we're going to be covering with me today is the probability and statistics section of the course. And I just wanted to preface by saying that some of the things that we're covering in this area of study is actually really applicable to real life. And as someone who's doing a Bachelor of Data Science at the University of Melbourne, basically all my math subjects since first year have always covered confidence intervals, hypothesis testing, and just working with different random variables. So to me, stepping into uni, doing specialist maths was particularly useful because of this area of study. So of course, if you specialize in other areas of maths, you'll definitely use things like differential equations, etc. But for me, and I think a lot of math subjects in uni, you definitely have to have a strong grasp of statistics. So it's really good to try and understand it and get the most out of it while you're still in year 12 and doing specialist maths, because it will definitely carry over. So what we'll be covering today is quickly the types of random variables, expectation and variance laws, linear combinations of random variables, which I just abbreviate as RVs, the sampling and distribution of sample means, confidence intervals, and hypothesis testing. Cool. So moving on to the types of random variables, this should all be very easy for you guys, hopefully by now. What's the difference between discrete and continuous variables? So discrete are countable things, and the main difference is that we describe the probability mass function as a mass function. So because it's discrete, we call it a mass function, whereas for continuous variables, we'll call it a density function, right? And this is the difference that you'll get when you're computing the mean or the expectation. So if it's discrete, you'll be using a summation. And if it's continuous, you do an integral. Okay, moving on to the expectation and variance laws. So again, these are very applicable when you move on to uni or just even do anything with data in real life. So knowing these laws is really helpful, not just for your exam, but also for when you move on to, if you move on to do higher maths in uni. So for random variables, X and Y, you need to know these rules. So the expectation of AX plus B, where A and B are both constants, means that you can just essentially take them out. So if it's multiplied by A, you just take the A outside and take the expectation of X. And if it's just plus or minus on the end, then you just take it out of the expectation altogether. So you just plus the constant. If you've got two different random variables here, you can see it's pretty much the same rule as above, but you can split them given that X and Y are independent. But I'm pretty sure for specialist maths, you will only really be working with independent variables, but that's a good thing to know as well. If they're independent, you can take the expectation of them separately. Then with variance, again, rules with variance, if you've got A times a random variable, you can take the A out, but it actually gets squared. And then if you have something like AX plus B, adding the constant on the end actually doesn't affect the variance. It only affects the center, which is represented by the mean of the random variable. So adding a constant doesn't actually change what the variance will be. And then essentially just adding on to that, if you want to take the variance of two independent random variables, again, same rule as above, you take the constant out, get it squared, and you add them together, okay? So I might just add here that if you have the variance of AX minus BY, it's actually the same rule, right? Because you don't actually change it to the variance of X minus the variance of Y. For variances, they're always added together. Okay, but if it's not in your formula sheet, I don't think they'll ask you something like that, but it is maybe something that you've seen before. Okay, and then moving on to the linear combination of variables. So this is really just building on the expectation and variance laws that we just saw. So here we're focusing more on the normal distributions. So the normal distribution should be something you're really familiar with for the statistics section of specialist. You'll be working with them a lot. So because you're working with the normal distribution, you have to know, again, properties of the mean and variance, because that's what you specify when you say X follows a normal distribution. You have to specify the mean and the variance. And typically, they always prefer to write the variance as the standard deviation squared, the Greek letter sigma. Cool. And you can see here they put the rule here again. If you take the difference of two normal random variables and you want their variance, it's still an addition sign. So you can see here, they're both additions. So try not to forget that. I see a lot of people see the negative and they just apply the negative. But if it's variance, you always add them together. All right, so let's see how this works in practice by looking at a question. This is from the 2019 VCA exam 2. So you can use your CAS for this. So let's see how we would solve this question. So highlighting key information, we have X and Y independent random variables. They each have a mean of 4 and a variance of 9. If the random variable Z equals AX plus BY, and this Z has a mean of X and a variance of 90, what are the possible values of A and B? So we know that the expectation, which is just the mean, the expectation of Z is going to be the expectation of AX plus BY, which you can then break up into the expectation of AX plus BY. So I wouldn't actually recommend writing all of this in your working out. If you can skip some steps, you can go ahead because it's just multiple choice. But just to explain this, first step to the next step is allowed because of independence. Independence. And then using our rules from before, we know that this is A times the expectation of X because we can take out the multiplied constant, and same with this one. So then we do A times, what is the expectation of X? Well, it's told us in the question, that's 4. And then it's the same for Y, so 4B. So let me just rewrite this. So this is 4A plus 4B, and this is going to be equal to 8, right? Because it told us that Z has a mean of 8, so that's where this 8 comes from. Okay, now for the variance. So again, variance of Z is going to be, so let me cut some corners here. A squared times the variance of X plus B squared times the variance of Y. Okay, and then subbing in what is the variance of X and Y? Well, they're both 9. So then this thing will turn into 9. That will turn into 9. So you get A squared, 9A squared plus 9B squared is equal to 90. Okay, and the 90 is because that's what it told us in the question. So now what you find yourself with is this equation here and another equation here. Okay, so then with these two equations, you can just solve them simultaneously. Again, it's exam 2, just put it in your CAS. So once you solve it simultaneously on your CAS calculator, you'll see that the answer will give you C. So definitely just utilize your CAS when you can. And just like we said earlier with the bound reference, if you forget the buttons to get to the solving simultaneous equations, put it in your bound reference. All right, so moving on to sampling. This is just kind of an idea that's introduced in specialist maths, and it's kind of important in big picture. So the whole purpose of doing sampling on any population, which is the big pool of all the total people, for example, is because from a sample, we try to do analysis on this. So finding statistics from the sample to try infer information about the population. And this is a really big topic that you'll, again, cover a lot in uni if you continue to do maths, because nowadays we can't afford to, find information about the whole population because we're too poor. And this COVID situation isn't really helping either. So what we do is we take a random sample from that population, do some statistics and analysis on that sample, and try say, okay, we're hoping that this sample is representative of the whole population. So for specialist maths, what you guys are focusing on a lot is the sample means. So something that you should be familiar with is the distribution of the sample means. Okay, so again, for specialist maths, we're just focusing on the normal distribution. So in summary, if you have a normal random variable called x, which has mean mu and variance sigma squared, then the sample mean, which is denoted by x with the line on top, which we call x bar, will follow a normal with the same mean. However, this time the variance is actually the original variance divided by n, where n is our sample size. Okay, and if you basically know this property, then the questions about sample means becomes much easier if you can just remember that you have the same mean, but your variance will now be divided by n. Okay, so moving on to confidence intervals, something that you'll see is that in real life, if you're like actually doing a report or something, you will never just write a statistic and say, okay, here, this is like the mean of, I don't know, some sample that you've sampled. Basically, all the time, you're also going to need to accompany that with a confidence interval, because with statistics, we can't always be 100% sure that the sample is representative of the population. So what we do is we give ourselves a bit of leeway and we put it into a confidence interval, and then we usually would report that. So for here, in specialists, you would just really need to know confidence intervals for the normal distribution, which I put a little bit of how it's derived here, right? But for questions, you really just need to memorize or understand this formula for the confidence interval. So for a 95% confidence interval, for example, which is shown here in the working, that's how you get it to this stage. But essentially for the confidence interval, you take your sample mean, so that is your statistic that you calculated, your sample mean, and then you will either minus some number z, where z you guys will probably use as 1.96 for the normal distribution, but this is what we would call our quantile, so how far away or how confident our measure kind of wants to be. And then this is our standard error, which is basically just the standard deviation of the sample. But remember, because it's a sample, we usually write the letter S instead of sigma. So sigma you can think of as the true standard deviation, but S is the sample standard deviation. So it's what we actually find from the sample that we picked. So for these, you can, again, kind of just find the numbers from a question and then chuck it into your CAS and get the respective numbers. There is also, I think, maybe a way to do it directly on your CAS, but I think it's usually easier to just find the sample mean and then plug in S, N, and the value of Z you want. Okay, so we are a little bit tight on time, but we will do this question very quickly. So this was a VCAR exam 2 question, and it was actually the last question of the exam, which almost makes it seem like it should be the hardest one. But for the statistics area study, it was actually okay. So there's quite a bit of reading with these questions, so definitely try reading it during reading time really thoroughly. But for this question, what you really have to concentrate on is these terms. So we have standard deviation of 15, mean of 375, normally distributed, and we have 2 independent random samples of 50 packets, and we want to calculate the mean mass of 50 packets for each random sample. So for part A, we need to find the probability that at least one random sample will have a mean mass of between 370 grams and 375 grams. And it says to give our answer in decimal places, which already tells you should be using your CAS somewhere. Okay, so just to quickly summarize this as well, we've got 2 samples and each has n equals 50, so sample size of 50. So to then do this question, what we're going to be writing down is we want the probability actually, might be easier to write this separately. So we want, just in general, we want the sample mean to be in 370 to 375. Okay, so the hard part of this question is realizing that for the sample mean to be in this range, it's either going to be a yes or a no, right? So this is a yes or a no question. So that means that you can actually use a binomial distribution to then calculate what is the probability that at least one of these samples will have a mean mass in between this. Okay, so that's like the general idea. And then we actually have to go in, how do we find that using our maths? So we know that X bar will follow a normal with the same mean as before. So this is using the formula from before. So the same mean stays the same. And now what happens to the variance? Well, it's the original standard deviation, which was 15, divided by our new sample size, which is n. So that's n equals 50. And I'm just going to write it as this all squared, because when we normally write the normal distribution, we will write the standard deviation squared as the variance. Okay, so we know that about X bar. So now we want to find the probability that X bar is in 370 to 375. Okay, so for this, don't freak out, just use your CAS. So of course, you shouldn't be writing CAS calculations in your working out, but for today, I'm just going to write this so that you guys know what to do. So to find if this is in your CAS or not, to find the probability in your CAS, you can write norm CDF of the lower bound, the upper bound, your mean, 375, and then your variance, so 15, your standard deviation, 15 over the square root of 50. So using this function from your CAS, it should give you the value of 0.4908. Okay, but then that's actually only the first half of the question, because remember, it asks us to find the probability that at least one random sample will have this mass. Okay, so we found the probability that one sample mean is in between these values is 0.4908. But now if we want to find that at least one random sample out of the two that we have, we'll have it. You can, again, like I said earlier, use the binomial distribution. So for this in your CAS, you would just write binom CDF 2, which is the n you have. So we have two samples. So maybe try not to confuse that with the sample size. So we have two different samples. And then our probability of success, so probability that the sample mean is actually in between 370 and 375 will be 0.4908. And then we put a lower bound and an upper bound. And the 1 and 2 here is basically saying that at least one out of the two samples we have will be in this range. So then if you put this into your CAS calculator, you will get the value of 0.741. And then that is your answer. So again, I know it might feel a little bit rushed because normally with these questions, you'd want to properly read through everything to try and understand the question. But I've kind of just walked you guys through the solution of what to do. Okay, so we don't have too much time left, so I'm just going to quickly cover hypothesis testing. So hypothesis testing is also probably one of the main topics in specialists that carry on to further study. So for hypothesis testing, the whole idea is that you propose a hypothesis, which we call the null hypothesis, denoted as H0. And this is what you think is the truth, but you're not sure. And then your alternative hypothesis, H1, is what you're trying to prove is either wrong or right. But normally in maths, we won't say you've proved it correct or not. You've just had enough evidence to reject the null hypothesis, your original, or you don't have enough evidence to reject your null hypothesis. So as we can see here, normally when you write a null hypothesis, it will always have an equal sign in it. So it might be something like H0, and it might be something like, you think the mean is 5. Okay, so that's your null. It should always have an equal sign in it. Then for the alternative hypothesis, H1, you might say, well, I actually think that the mean is greater than 5. Okay, so you can see how this is what you think is true, and this is what you want to test it against. Linking to this, you also have p-values, where a p-value is the probability that essentially what you've observed in your sample data is more unlikely than what your null hypothesis is kind of telling you. So it's basically a probability of you getting something crazier than your results. And if that probability is really small, then we normally have evidence to say that the null hypothesis shouldn't be true, right? Because you would expect a sample data to not have something really, really, really rare, okay? And if it's like 0.001, then you know that, well, that's a really rare chance, but I did see it, I did observe it. So most likely your null hypothesis is wrong. So just remember that the p-value is also calculated assuming that the null hypothesis is true. So that's something else to look out for as well. So there are some other things I was going to do today. So some extra questions and working out, but I think I'll just skip that for the sake of time and move on to... Sorry, guys, I think my internet dropped out. Can I just confirm that I'm back? Okay, great. Thank you. Sorry for the interruption there. But yeah, I was basically wrapping up anyways, just about the type 1 and type 2 errors. Just make sure you have that table in your bound reference. All right, cool. So just before we end up, we will open up a survey for evaluation and some of your feedback. So I will share that on the screen. All right, cool. Can everyone see the survey link? So let me just copy this. Oh, thank you. It's already in the chat. So basically, to wrap up this session, we would just really appreciate if you guys could fill out this survey and give us some feedback about how you found this lecture. Yep, so the survey is in the chat. Oh, yeah, thank you for that. And also an emoji to show us that you've actually done the survey would be great too. So I'll just give you guys a minute or two to do that. All right, cool. So thank you for those who have sent in the survey, and please make sure that you do fill out the survey so that we can learn from it and hear some of your feedback and how you felt about it. So just wrapping up, just a little note that unfortunately we could not cover the whole of the specialist content in only a 3-hour recap lecture. So yeah, definitely try and look more on the study design in the VCAL website to kind of tie all your studying together. But hopefully this was helpful, and hopefully you did get something out of it. And it was just some good refreshers from some of the content that you might not have touched for a while. Cool. And one last confidence rating. So this should be on the Mentimeter. If you guys want to jump onto there and rate how you're feeling now about the specialist exam. Cool. So I'll have to switch my screen sharing to that. All right, cool. So looks like we're kind of sitting at like a 7.4 for our confidence, which is a good improvement from the start of the lecture. So that's good to see. Okay, so I'll stop sharing that one now. All right, and that is the end of the PowerPoint presentation. So just wanted to say a massive thank you to everyone who stayed throughout the whole thing. I really hope that this was useful to you and that you got something out of it and that you're motivated to keep studying and to smash out your exam coming soon. But yeah, just remember that you've worked hard the whole year, and I'm sure that you guys are more than capable of sitting down and doing the exam. It's really just preparing yourself to not stress out and to just perform your best in the situation that we're in. So yeah, does anyone else have anything to add, any of the panelists?
Just another thank you from me as well for everyone sticking it out for this whole today's session. And like Chelsea said, you guys are definitely in the best position possible. You guys worked so hard. No matter how weird your year 12 or year 11 experience may have been, you've gone through it, and I'm sure you guys do amazing in the exam.
Yeah, totally agree. So thank you everyone for coming. And I think that this is the end of the session now. Thanks, everyone.